Hi, this is Mr. Phillips, and I'd like to talk to you about our Activity 8.3 modified. In this instance, what we're going to do is we are going to use the Cooper chloride along with the 50 milliliters of water, but this time we're going to increase our aluminum to zero point 0.8 grams of aluminum foil, and then we're going to reset our lab, and we are going to try the 5 grams of Cooper chloride with 50 milliliters of water, but we're going to try steel wool for the second trial. And so you can see here, this is what we used in our activity. The first time we did this activity with activity 8.1 modified, remember we used 0.5 grams of the aluminum foil. So we are making a comparison here by saying, well, what happens if we increase the mass of the substance? What does that do to the amount of chemical energy and therefore the amount of thermal energy? And then in the second part of this experiment for activity 8.3 modified is we're going to say, well, what if we switch the substance type from aluminum foil to steel wool? And so we're going to use the 0.5 grams of steel wool to compare to our 0.5 grams of aluminum foil in activity 8.1 modified. All right, so we were supposed to make some observations, and the quantitative observations that I came up with was that this time I went from 22 degrees Celsius all the way up to 66 degrees Celsius when I used the 0.8 grams of aluminum foil. That's a temperature change of 44 degrees Celsius. That's quite substantial. Comparing activity 8.1 modified with the 0.5 grams aluminum foil, the temperature change was only 30 degrees Celsius. So by adding only 0.3 grams aluminum foil to the solution versus the 0.5 grams, we actually bumped up the temperature by 14 degrees Celsius. Other observations, the qualitative observations, were very similar to what we saw in activity 8.1 modified. The difference was that we had an increase in temperature change by 14 degrees Celsius. We had a little more chlorine gas produced, and it appeared as though we had a little more copper produced than what we had the first time. And you should have noticed larger bubbles. All right, number 3. Is the thermal energy of the mixture larger or smaller after putting in a bigger piece of aluminum foil for activity 8.3, 0.8 grams, as compared to activity 8.1, the 0.5 grams? Well, this should be pretty obvious. It did increase. So the temperature change for the 0.8 grams aluminum foil was a change of 44 degrees Celsius versus a 30 degree Celsius temperature change for the 0.5 grams aluminum foil. There was more thermal energy for the 0.8 grams aluminum foil than the 0.5 grams aluminum foil. If there was more thermal energy when more aluminum was added, where does the additional thermal energy come from? The second part of the question, you notice I just struck through because it's really not relevant because we really did have an increase in thermal energy. And so to have an increase in thermal energy, that means that we had more of a chemical reaction, in other words, more chemical energy to start with, to convert into that thermal energy. This is really a pretty awesome lab when you know the chemistry behind it. This is called a single replacement chemical reaction. And if you really like to get into chemistry, this would give you an example of what's going on. So basically what we did was we took our aluminum foil and put it into the cupric chloride solution, which was the greenish colored crystals mixed with the water. And what happens is that we are literally causing the aluminum foil in this reaction to switch places with the copper that's dissolved in the Cooper chloride solution. As a result, we end up with our Cooper chloride plus aluminum yielding copper plus aluminum chloride. So the CuCl2 is our Cooper chloride, the Al is our aluminum foil, the yield sign is the little arrow. The products then are the copper and the aluminum chloride. The Cooper chloride plus the aluminum, those are our reactants. So these reactants yield these products. So what did you observe with the steel wool mixture? The quantitative data. I have to admit, I was quite disappointed with the steel wool. I was hoping we'd have more of a reaction than what we did. The steel wool for me, 0.5 grams of steel wool, was a whopping 4 degrees Celsius increase in temperature. That was a real letdown. I was hoping for more. Compare that to our 0.5 grams of aluminum foil in activity 8.1 modified, where we had a 30 degrees Celsius temperature change. So it's quite a substantial difference there. So what did you observe with the steel wool mixture? So what's our qualitative data? Well, this time I ended up with something that looked like a different substance. The color of the solution changed from blue to green for me. The steel wool changed color. New substances appeared. It became rusty looking. And actually there was some copper, and the reading of the thermometer increased a few degrees Celsius. Only about 4 degrees Celsius for me. Is the thermal energy of the mixture larger or smaller after putting steel wool in with copper chloride as compared to the same mass of aluminum foil? Well, if I refer back to my data from activity 8.1 modified, I'd realize that the steel wool was a much smaller chemical reaction, therefore I had a lot less thermal energy. So the thermal energy for the 0.5 grams of steel wool is much smaller, 4 degrees Celsius temperature change, as compared to the 30 degrees Celsius change for the same 0.5 grams of aluminum foil. So the type of material definitely makes a difference in the amount of chemical energy that's available for a chemical reaction, and then therefore to convert into thermal energy. So why did the thermal energy of the mixture increase less when you put the steel wool instead of the aluminum foil into the solution, even though they both had the same mass? Well, the thermal energy for the steel wool mixture was smaller because different substances, like steel wool versus aluminum foil, contain different amounts of potential chemical energy to be converted into thermal energy. Again, our chemical reaction here, if you're into chemistry, if you notice, we still have our reactants on this side. The arrow means yield, and these would be our products. So we have cupric chloride plus our steel, our iron, Fe, yields copper and iron chloride. So that's what we were getting, okay? All right, so making sense questions. What factors determine the amount of chemical energy an object has? So this is ultimately what we're trying to get to with this activity. Mass and type of substance influence the amount of chemical energy the substance has, which is transformed into chemical reactions. Give an example of chemical energy in your daily life. There are many examples you could list. I just chose some really basic ones. So we get chemical energy from the food that we eat. Chemical energy is stored in the fuel we used in vehicles and in heaters, or water heaters if you have a natural gas or propane powered water heater, in our furnaces if you have natural gas powered or propane LP powered furnace or heater of some sort, your grill if it's a gas grill, and chemical energy is also in batteries. And we'll talk about batteries later in our book. So, scientific principles for chemical energy. Number 15 says, chemical energy is transformed into other types of energy during a chemical reaction. And I listed a few examples for you. So kinetic energy, thermal energy, and light energy. And number 16, the chemical energy increases as the mass of an object increases. The type of the substance an object is made of influences the amount of potential chemical energy it has.